very few with everything in there, but I'll show you how to work that. I'll also show you the graphing calculator and how to access a table, because many of the professors who teach this with me on the final exam, they like to include 5 points on the graph as part of what you need to provide when you graph it. Okay, it's really simple. We'll make a table of values, but I'll also show you on a graphing calculator how to find a table of values for any graph and where that graph, what that graph looks like. And it's pretty simple. The other section is on also graphs of parabolas, but mainly from standard form. So we're going to dig out information that's useful to graph. We're going to find the axis of symmetry. It's a calculation. We're going to find the vertex. It's a calculation. We're going to find the x-intercepts, which pretty much is either factoring or quadratic formula. Most of them are probably going to be factoring, okay? The y-intercept, which is really simple to find. And then there's one problem that says, hey, go from standard form, which is this right here, and change it to vertex form, which is this right here, okay? There is a process that involves completing the square to do that. It's not fun. It's not terrible, but I have an easier way, okay? And I'm going to show you the easier way. It's much, much better. We're going to look at domain and range. I pulled up the PDFs for some of these because there's some check the boxes things on some of them, just so you understand when you look at a function, the equation for a parabola, you know what it should look like based on certain things. Okay, so there's a little bit of graph reading, there's a little bit of analysis of graphs. Other than that, it's actually pretty quick. I'm kind of hoping to not be here until 7:40, okay? So, all right, I'm going to turn the page and get to a grid. Did anyone have any questions while I get this going? Does anyone have any questions from last time? Questions in general? If you don't have a graphing calculator, if we're done early and you've got your laptop and you don't have a graphing calculator and you want that calculator thing I have on your computer, I can put it on there literally in about 5 minutes or less. Okay, so we're going to graph. Y equals 2x squared. Okay, so let me draw a quick set of axes. Let me talk to you about what the 2 is doing. Okay, in general, what this thing is going to look like. So when you have a value in front of the quadratic term, like a 2, what that does is it makes the graph more narrow. Because when you square something and then you multiply it by 2, the value jumps up quickly, okay? When you don't have any set of parentheses like the x minus h, you don't have something added after the fact, this parabola just essentially looks just like x squared, except for it's narrow. Now, let me put the graph of y equals x squared up there as a reference, just real quick, so you know what we're comparing it to. So the graph of x squared goes through 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 4, 5, 6, 7, about 8 or 9. Let's just pretend that's 9 right there, and negative 9, or negative 3, 9. Okay, I've got a graphing program, but this works for now. So that's x squared. When we look at the graph of 2x squared, I'll do it in that color, it's just going to be narrower. It's still going to go through 0, 0. Okay, it's going to be symmetric to the y-axis. It's just going to be more narrow. So when we do this, we're just going to make a data table. So it's going to go through 0, 0. Like I said, they will put, so Dr. Bell, Dr. Barnsley, Mrs. Parks will put a data table on your exam to fill out. okay, because they want to see that you understand how to make that table, where that graph is. We're going to use 1, but this time when I use 1, I get 2 instead of 1, 1, because I got to get square 1 and multiply by 2. And then I get negative 1, square negative 1, you get 1 multiplied by 2. So what you're seeing is, you're seeing what I call reflection points. Every parabola has what's called an axis of symmetry that cuts it right in half, right smack down the middle of the very bottom, which is called the vertex. So in this case, it's the y-axis. So every point on the right has an image on the left, and vice versa. Okay, when I put in positive 2, square 2, you get 4 times 2, you get 8. And that means that negative 2, 8 is also going to be on the graph. So I go 2 up to 8, negative 2 up to 8. So the graph of 2x squared in comparison to x squared, it's just narrower. That's all. Okay, because the 2 is what it's doing is it's stretching it. That 2 represents a vertical stretch. It's pulling it up away from the x-axis. Okay? So that's what an A value does. A number in front of the quadratic is going to make it narrower. If it was less than 1, let's say it was a half, it would just make it wider. All right, now, if we add something after the fact, so let's look at the graph of y equals x squared minus 5. Right, what is that 5 going to do? Or I should say, what is a negative 5 going to do? All that's going to do is take the graph of x squared, and it's going to translate it 5 down. So instead of being at 0, 0, it's going to start at 0, negative 5. So again, making a data table, it's now starting down here. So if I put as in dotted, okay, here's the graph of x squared. I'll just dot it in there. Nice and symmetric, beautiful graph. Okay, all I'm going to do is pull the whole thing down 5 units. So if I put in 1, I get negative 4. If I put in negative 1, I get negative 4. Instead of 1, 1, negative 1, 1, it's down here. I put in 2, I get negative 1. I put in negative 2, I get negative 1. So squaring the 2 and the negative 2 gives you 4. 4 minus 5 is 1. So the graph of x squared minus 5 is the same size as x squared. It's just translated down 5 units. Okay? When we get through a few more examples, I'll show you again where the stuff is in your calculator, but then I'll put it all together in terms of when you see a function, you can predict and actually say exactly what this function is going to do. Okay? Any questions so far? Okay, so we made it narrow. We moved it down. Now, let's take a look at, and they use function notation, so maybe I should be more consistent here. They're using function notation, which that's just another way of saying, hey, this is y, not f of x, y, it doesn't really matter. Let's do that. Okay? Any idea, or even if you know what that's going to do? Does anyone know what that's going to do? Would you guess right versus left? Because it's plus? You'd guess that, right? It's actually 3 to the left. The pattern for left and right is a subtraction-related pattern. So this is similar to subtracting negative 3. So when you see plus, it's actually going to the left, when you see minus, it's going to the right because the pattern for the translations left and right is a subtraction pattern, not an addition pattern. So this actually represents a translation of 3 to the left. Okay, so now instead of being at 0, 0 and being symmetric to the y-axis, I'm going to go over here 3 to the left. 1, 2, 3. And if I start making my data table again, I've got -3, 0. Sorry about that. That's not what I wanted to write. I didn't want to write that. -3, 0. Now think about that parabola being to the left and right of -3. Those are the numbers that you're going to want to pick to graph the rest of it. So I want to put in -2. -2 plus 3 is 1. 1 squared is 1. And here's where it becomes quick. If -2, 1 is on the graph, on the other side of that vertex, -4, 1 is on the graph. It's image because of the reflection. If I put -1, that's going to give me -1 plus 3, 2, 2 squared, 4. So if -1, 4 is on the graph, well, 1, 2, 3, -5, 4 is also on the graph. So on each side of where the parabola is split down the middle, you have points that are images of each other. So for every 1 point you graph, you automatically get a second one. So if I graph 3, I automatically get 6. You see how this works? Okay. All right, now let's put together some of these transformations. Okay, so now I'm not going to do a stretch or compress with it yet, or an upside down, but we'll get to that. So now let's look at, we'll use H for, why the heck not? Let's go x minus 2 squared plus 3. And I will summarize all of these and compare it to the vertex form I had in my agenda, so you know exactly what's going on, and that should make it to your note sheet too. That should make it to whatever you're going to use next time we take a quiz or an exam. Okay, so this is going to be 2 to the right, because it's a subtraction, not an addition. Add is left, subtract is right. It has to do with the x-intercepts. And this is going to make it go 3 up. So remember that the parent function x squared, the very bottom is at 0, 0, and it's going like this. Okay? That's what it's doing. So now we're taking 0, 0, and we're moving 0, 0, 2 to the right, and 3 up. And of course I sketched that, and now it's in my way. Okay, so we're going from here to there. Now there's the bottom, the vertex of the parabola. That's why it's called vertex form. It's called vertex form because the vertex are the values of h and k, which in this case is 2, 3. X minus h squared plus k. I've got a model right here of x minus h squared plus k. There it is, 2, 3. And now, to make a table of values that would fit this graph, I already have 2, 3. I want to pick 1. So 1 minus 2, -1. 1 plus 3 is 4. And then I automatically get 3, 4. I picked 0, because it's the next one over here. I get 7. What is this? 5, 0, 7. I automatically get 4, 7. And there's your 5 points. Vertex is always one of them. Get 2 on the right, you automatically get 2 on the left, or vice versa, however you want to put it in there. And there's your parabola. Okay. Any questions so far? I like vertex form because you don't have to dig for so much stuff. It's all right there in front of you. All you got to do is just know what's what in terms of left, right. Up or down is up or down. It's plus, it's up, it's minus, it's down. But left and right are the ones that are backwards. Okay, so before we get to adding any other things like flip it upside down and stretch it with moving it around, let me just kind of break this down for you. So that value right there does one of two things. It makes it open up or down. Up when it's positive, down when it's negative. Okay? It also makes it narrow or wide. Narrow when it's bigger than 1. Wide when it's between 0 and 1. So if I saw 1/3 in front of the parentheses, or a 1/3 coefficient on the x squared, I can expect that parabola to be wide. If I see a 5, the thing is going to be super skinny, really narrow. Okay, our h value moves it left or right. When you see a minus, it's going right. When you see a plus, it's going left. So if I, just as an example, x minus 2 squared is 2 to the right. X plus 5 squared is 5 to the left. It defies what you think because it's a subtraction pattern. This is up or down. And it is what it is. When k is positive, it goes up. When k is negative, it goes down. So that behaves exactly like it's supposed to. Okay, so positive, negative. Okay, now if this a value is negative, so it opens down, it'll be upside down if I see a negative number right there. It'll be flipped upside down. It'll go down instead of up. Okay. Now, so there's then just a few, let's do one more, and then I'm going to jump to the PDF to show you also what you have to look at. Okay, what am I doing? I don't want that. Could end up making a parabola graph with really, really wide writing. Okay, so let's put together, let's do -2 x minus 1 squared minus 3. And I also want to show you the graphing calculator. You can type all these things in exactly as you see them. It'll graph it for you. I'll show you how to access the table of values. Not that I'm not saying you can't do it mathematically and numerically. I'm not taking that from anybody, but it avoids errors. People, when they square negative numbers, make sign mistakes. What happens? So let's take a look at this thing. This -2 is going to do two things. It's going to make it open down. So it's going to go like that. And it's going to stretch it out. It's going to make it narrow. That's going to be 1 to the right. And that's going to be 3 down. Okay, so what am I moving 1 to the right and 3 down? What's going 1 to the right and 3 down? I mean, the whole thing is but specifically what starting point is going 1 right and 3 down. Zero, zero, okay? So the bottom of the parent function, the bottom of your standard x squared parabola is at 0, 0. So now we're gonna go 1 to the right and 3 down. That's our vertex. 1, -3. I use y. They're gonna use h of x, g of x, f of x, q of x, all kinds of x's. Okay, just function notation. So, all right, what number should I pick then? What's my next number I should pick? Either 2 or 0. One of them. If you pick 2, whatever you get for 2, it automatically gets 0 and vice versa. So whatever's easiest. Okay, let's use 0. If I put in 0, that makes it -1 squared, which is 1, times 2 is -2, minus 3 is -5. So 0, -5, you just got to go through the arithmetic. I went -2 times 0 minus 1 squared minus 3, and that turns out to be -5. There it is. Which means that 2 -5 is automatically on the graph. It's on the other side. That's the whole reflection symmetry of a parabola. Whatever you get on the left, you automatically get on the right, and vice versa. So now I would just have to find one more point. I could probably put in 3. So -2 times 3 minus 1 squared minus 3, 4, -8, -11. So it's down there. All right, somewhere down there. That's not -11, but you get the picture. Okay, it's down there somewhere. So knowing what those numbers do, it was 3, -11, which also would give me -1, -11, because that would be on the other side over here. So knowing what these numbers do in vertex form, especially where the vertex goes, gives you the starting point of where to start putting your numbers to draw your graph. Okay, for those who are going to have to do it manually or don't have a graphing calculator. Now, I want to show you before I get to anything else in this section, which there's just a whole bunch of the same thing. There's not much of anything. Well, there's some graphs, and we'll talk about that. It's just knowing what the graph should look like based on the value of A, but I'll get to that in a second. Okay, what I want to show you is I want to show you the graphing calculator. How do I do? Oh, there. Whoops, sorry. Share screen. It's going to lock up on me probably first because it always does. Yep, it's paused. I'm not sure why it doesn't like my graphing calculator. Maybe it just doesn't like me. Oh, there we go. Okay, so, all right, I got to move this up. I'm afraid if I punch the on button, I'm going to end up hitting the stuff down here for Zoom and end up making a mess. So in your y equals menu of your graphing calculator, a graphing calculator, you can put in functions. I'm going to put in that -2. Don't use a minus sign, it'll give you a syntax error. Parenthesis, your independent variable x key is right there, where it says link, that's xt theta n. It was minus, what was it, -1? Something. Hit the squared key to get your exponent, or you can use a caret, either way. And then it was -3. So that was the one we just got done graphing. When you graph anything, for the most part in this class, you can probably do what's called a zoom 6. So when you hit your zoom key in the middle of your keypad, the zoom 6 is a standard viewing window. What that does is it sets your calculator to go from -10 to +10 across the X and Y axis, even though the screen's not square. Okay, so if I do a zoom 6, there's my parabola. Okay, now, anytime you put a function into your calculator, you automatically get a table of values for every single one of them. All you got to do is make sure you go find it where you want it to be. That's above your graph key. It says second, it says a table up there. But first we got to set it up. So if you do a second window, there's your table setup. I don't want to start the table at 6. 6 is too far to the right. I want to start the table safely at 0 because you can always scroll to get where you want. So I'll start the table at 0. I want the table to go up and down by 1. So that little symbol right there stands for the change in the table increments. I can change it to whatever I want. I'm just going to do 1. And then I'm going to go to second graph, and that's going to take me to the table of values. So there's my vertex at 1, -3. Let me scroll up just a little bit, okay? So you can scroll up and down in the X column, but you might get stuck in the Y column, so don't do that. But you see the symmetry in the numbers of the Y column? You got 1, -3, you got 0, -5, 2, -5, -1, -11, 3, -11, 2, -21, 4, -21. That's the type of numbers you want to find when you're trying to go to the table and get your table of values to pick out where you're going to graph. If you know where that vertex is going, that's essentially where you want your table to go, because then you're going to see that symmetry and your graph pops out really simple. Okay? Again, anybody wants this little calculator on their computer, I can stick it on there for you. It takes 5 minutes. It's really helpful. If you've got a graphing calculator, then hey, you're all set. If you don't have one, it's okay. I mean, you can still do it manually. You're just going to be doing calculations that are manual. Okay. I'm still sharing my calculator. I don't want that. We good so far? Okay, so again, the remaining parts of the lesson are just a bunch of graphs. You're just graphing a whole bunch of things. So if you look at, let's say this one right here, we're not going to take the time to do this right now, but -3x² plus 2. So what does the -3 in front of the x² do for us? Does it make it narrow or wide? Narrow. Because it's negative, it flips it upside down. And what does that plus 2 do? Because it's not in parentheses. So it's not 2 left. It's 2 up. So the vertex 0, 0 would go to 0, 2. It wouldn't be going left or right at all. I'd be starting at 0, 2, and then things are going to be really super skinny, opening down towards the bottom of the page. Okay, what I wanted to show you and share with you is another concept that we're going to do here, but we also are going to end up probably doing it again about quadratic functions. Okay, so here's the graph of a parabola. It says the vertex is at -2, 1, as shown. Okay, it says to find the domain and range. The domain is your input values, your x values. The range is your output or your y values. Now, I wish I could write over the top of this with my computer program, but because we're Zooming, I can't do both simultaneously. I can only do it if I'm not Zooming. So, but I'll write it down on the pad in a minute. Unless otherwise told, the domain of a quadratic function is the set of real numbers, all real numbers. Now, I don't know if Alex is going to let you put all real numbers as an option. I'll show you how to do the interval notation. Okay, there are no restrictions on the x values going left or right, not one. Okay, anyone know what the range is? How do you determine the range? Right, where's the bottom of the parabola? At -2, 1. So the y value at right here is 1, and all the y values are greater than or equal to 1. Because everything's above. That's your range. Okay? So let me get back to my writing program because I need to write this for you. So that graph, so the domain of any parabola is a set of real numbers. I don't know if they're going to let you choose all reals. There's no restrictions on the domain of a parabola. As an interval, it's anything from negative infinity to positive infinity. There isn't any restriction. It doesn't matter what it is. It's just a real number. The range of that parabola, the vertex was at negative 2, 1. The negative 2 has nothing to do with the range. The range is your y values. The domain is your x values. And all the y values in that parabola were above or equal to 1. So I'll give you the range several different ways. As an inequality, it's greater than or equal to 1. If we were doing set builder notation, which eventually we're going to do set builder notation, it would look like this. It's a set of all y values where y is greater or equal to 1. As an interval, it's 1 to infinity. So there's several different ways that you could express the domain or range of a function depending on what is asked. And I have seen the ALEKS programs in different assignments ask all of them, especially the interval and the set builder. They go back and forth between the two of them. That's just part of what you have to try to learn and pick up on. Okay, so your range values are related to the y value of your vertex. If you know where your vertex is, the range values are either equal to or above it if it opens up, less than or equal to it if it goes down. Okay, and we're going to get to that because I think it's the next section, section 5, has some other domain and range things in it. Okay. All right, are we good so far? I'm gonna go back to that other PDF because there's images I need to show you and go through some stuff. And there's one graph we have to just translate, and that's really a simple thing to do. Okay, so let me go back to that. How are the Zoomers doing? We good? Oh, I'm seeing thumbs up. Yep. Okay, confetti for me. All right, back to this. Okay, now, this is all about understanding, is that too big? This is all about understanding just what your quadratic coefficient does. So you have 4 different graphs. You've got ax squared opening up, bx squared opening down, but a little wider than that one. Cx squared opening up, but way wider than that one. Dx squared opening down, the skinniest of all of them. So when you look at these, this is that value in front of your quadratic that opens up or down, narrow or wide. So then they're just going to ask you to run an analysis about whether A, B, C, and D are positive or negative, which one is biggest, okay, which is the greatest value, least value. Okay, so as you go through, it's little check boxes. Okay, for each coefficient, choose whether it's positive or negative. Well, A and C are positive, B and D are negative. That's just the open up or down part. Okay, choose the coefficient closest to 0. Well, closest to 0, or you tell me the one closest to 0. I can't see the Zoom people giving thumbs up for, okay, anybody thumbs up for A? B? C? I'm picking C. It's the widest, so it's the one that's less than 1, more so than any of the other ones, okay? So the coefficient that's closest to 0 has to be C because it's the widest, so it's the smallest value. That's what makes it wide. choose a coefficient with the greatest value. Now that's kind of deceiving. Greatest as in the skinniest is going to be D, even though D is a negative number. Greatest value in terms of comparison, positive, negative, would have to be A. So I'm not, that's kind of an ambiguous question, right? The greatest positive value is A. The greatest negative value is D, because it's the narrowest. So I'm really not quite sure what they want for that one. Okay, I'm going to say it's D because that's the skinniest. Okay. All right, now, I think that's not too terrible. So I think we can answer this really quick. So x squared, we already talked about x squared. What about x squared plus 3? What is that going to do? What's the plus 3 at the end going to do? It's going to move it up 3. Okay, that's really simple to do. And I think this one is also not a terrible thing. Okay, so you've got the function 3x squared plus 4. So the plus 4 makes it go up. The 3 makes it narrow. Now what we want to do is we want to translate it down 9. So we're going to slide it down 9 units. So instead of 3x squared plus 4, we're now going to have 3x squared take it down 9. 4 minus 9 is -5. Okay, so you just have to understand which part of that function, A, H, K, are doing what things. Left, right, up, down, wide, narrow. So that's kind of what this section is all about, is just understanding what parts of those parabolas are being affected by which values and how to change them. Okay, that's essentially it. And that's that. We still hanging in there? You gotta get out here early, don't you? All right, let's get through this without a break. No break today. Let's get out of here. Okay, now, standard form. I don't think it's a very good beach day, but you know, there's, I'm sure, other things you guys want to do. Okay, standard form takes some digging. So before I get to some specifics and share that PDF and go through a bunch of things, let me just give you all the specifics. Let's just get all the little general note stuff out of the way right now. Okay, so this A value still does the same thing it did before. It's up, down, open, down, narrow, wide. Still the same, no different. So makes it open, up or down. Narrow. That's narrow right there, or wide. Okay. At least my pen's working. I put the batteries in it. It's not freaking out like it was last time yet. There's still time. That right there is your y-intercept. Your constant value is your y-intercept. If you put in 0 for x, you're going to get y equals c. Have to. So that's a free thing. That's the only thing you get free. The other things you have to calculate. Now remember, I was saying that every parabola has an axis of symmetry that splits it down the middle, and the vertex is at the very bottom of the parabola. Those two things you actually have to go calculate. Okay? So the axis of symmetry, which they're going to ask you to write, it's a vertical line, and it is the value x equals minus b over 2a, opposite of b over 2a. That's your axis of symmetry. We'll do a specific example and we'll go through it, okay? The y value, I got to remember this. I think, I'll double check this in a minute. I always forget this one. I'm pretty sure it's that. I'm pretty sure it's that. Hold off on this one. Okay, write it down, but I may have to fix it. After I do a specific example, I'll know for sure. I always lose track of that one. I always just take the X value and plug it back in is what I do. I get the axis of symmetry, which is the X value. I stick it back into the parabola and I just calculate it by hand. It's not that difficult, but I want to give you the right information. So just hold off on that. Okay, so your vertex then, the vertex is whatever you get for the axis of symmetry. That's your X value of your vertex. Okay, so the X value is whatever that is, and the Y value is whatever that is. That's your axis of symmetry. I mean your vertex. That's your vertex. That's the bottom of the parabola where things are reflecting across. But specifically, you're going to have to identify the axis of symmetry as it's a vertical line, X equals something. Okay. Now the reason we want that, because if you find the vertex, you got the axis of symmetry, then you can pick points on both sides and you get the graph really fast. So that's why we want to find it. And once we find it, everything else, it goes quickly from there. Okay, and if it's close to the y-intercept, wherever the axis of symmetry is, the y-intercept, you can slide across and get an image point and you've got 3 already. Okay, so it actually isn't terrible. Okay, so let's say we have, I'm not sure what that is. Y equals x squared plus 8x plus 7. Okay, we also have to find the x-intercepts. So we're going to find a bunch of things about this quadratic. We're not going to graph it, but we're going to find a whole bunch of things about this quadratic. Some of the things you're going to just dig off the graph, but we're going to graph this and get everything that we possibly can about this parabola. Because sooner or later, you need to know everything there is to get. X-intercept, y-intercept, axis symmetry, vertex, all those things. So let's find the vertex. So to find the vertex, because I want to graph this, I've got to find the axis of symmetry. Okay, so my A value is 1, my B value is 8, and my C value is 7. So my axis of symmetry is -8 over 2 or -4. That's also the X value of my vertex. So my vertex is somewhere at -4 something. Okay? Now, just to check that -b squared over 4a plus c, I'm going to put the -4 in here and do it manually. Then I'll do the one I was questioning, and I'll hopefully it's the same. Okay, if not, I'll just have to dig it up somewhere. Okay, so if I do -4 squared plus 8 times -4 plus 7, 16 plus -32 plus 7 is -9. Thank you. I was waiting for that. Yes. I'm finding the y value. Yes, I'm finding the y value. What I did is I took the -4 and plugged it back into the equation. So I'm finding the y value. Okay, so it should be -4.9. Now, before we move on, let's check that other thing. Okay, let's check it against -b squared over 4a plus c. Let's check that. So it's going to be -8 squared divided by 4 plus 7. Okay, that's an opposite. Now this isn't -8 times -8. It's the opposite of 8 squared. So this negative sign is not in with the b. It's actually that. Okay. Well, negative 64 divided by 4 is 16. Negative 16 plus 7 is negative 9. I think I'm okay. I'm pretty sure that's right. If it wasn't right, there's no way in hell that I just got lucky. There's no way I just got lucky, okay? So I'm pretty sure that's the y value of the vertex. So there it is. All right, now your y-intercept is 0, 7. Okay? Here's the big question. If you're asked to find the x-intercepts, what are we looking for? The places where it crosses the x-axis, right? Okay. Does someone remember how to find those? There's a one-size-fits-all process for it, but it's going to be longer than the one I gave you. I gave you a nice one. You could get them out of your table on your calculator. The quadratic formula are your x-intercepts. However, I want you to always look at the thing first. Does x squared plus 8x plus 7 factor really fast? It factors really fast. It factors to x plus 7, x plus 1. And if I set these equal to 0, remember we were solving the quadratics and setting them equal to 0 and finding those are your x-intercepts. So your x-intercepts are going to be negative 7 and negative 1. Because when you do this, that is exactly what you're finding. Your quadratic formula is your x-intercepts. Or factoring, set equal to 0 are your x-intercepts. I like to actually record them as actual points. Negative 7, 0, negative 1, 0, because you know what they are. I think the Alex program actually lets you just put in the numbers and separate them with a comma, saying, hey, it hits at negative 7, hey, it hits at negative 1. I know what intercept means. Okay, so that's everything you can find in that, except for the graph. So now if I'm looking at the graph of this thing, I'll graph it quickly, and that's the whole purpose of finding this stuff is to get the graph. So its vertex is negative 4, negative 9. I think that's right there. Or is it 4, negative 9? Negative 4, negative 9, right? It hits at 0, 7. 1, 2, 3, 4, 5, 6, 7. So right here, on the other side of x equals negative 4, 4 units over here, 1, 2, 3, 4, is negative 8, negative 8, 9, or negative 8, 7. So negative 8, 7, and 0, 7 are on your graph. Your vertex is right there. Pick any of these right here, and you're going to get the points you need. Okay? So in standard form, you got to dig through and find everything you need to graph. Okay? Any questions about that one? I kind of lumped a bunch of things into the same example. And as we pick out through some of the things in the PDF, it's not everything that you need to have, but you need to know it all sooner or later anyway. But every problem doesn't ask you for all this stuff, but you need to know how to find it. Okay, let me jump to that PDF. Some of them are just graphs, graph. X-intercepts. Yeah, this is actually not terrible. Okay, let me get to a few things off the PDF. Oh, we're going to be out of here early, I can tell. I think. I want this one. Okay, so here is the start of section 5. But this is from a graph. Okay, so it asks, hello, is it opening up or down? Up. Find the intercepts. For both x and y intercepts, make sure if there's more than one, separate them with a comma, so it doesn't want ordered pairs. Okay, so x intercepts, I just need to read the graph. I think that looks like 6 and -1. So you just have to record as at -2. -2. 6 and -2. Y-intercept looks like -6. So you're just reading the graph for this one. Coordinate of the vertex. Where's the bottom? Looks like 2, -8. Okay, so there's the vertex. Axis of symmetry. Equation for axis of symmetry is x equals whatever the x value is. In this case, x is 2. So x equals 2. Your axis of symmetry is a vertical line running through the vertex. Okay, so this, all you got to do is just read the graph and put in what you're putting in. The rest of them are more about just, here, graph this. Graph it. Okay, but before we get to an actual graphing, and then there's a couple of other things I want to do. There's a few other things I don't want to have to write down specifically. So I'm going to just scroll through. There's a graphing one. We'll come back to that. There's another graphing one. There's another graphing one. 5 halves is a pain. Okay. We'll get to that. That's actually not bad. Okay. So let's look at problem 5. Then I'm going to show you the quick, simple, painless way to do problem 6. I'll go back to the screen thing. We'll do a couple graphs. The application problem, I think, is pretty simple. It's just a quick application of the vertex. And then there's a little checkbox in terms of the vertex being a minimum or maximum. And so you got to find the vertex. So you need to know where the vertex is in order to answer. Okay. It's a minimum if the graph opens up. It's a maximum if it opens down. Okay, so x-intercepts of x squared minus 6x minus 7. Always ask yourself first, can I factor it? Does x squared minus 6x minus 7 factor? Yes, pretty quick too, doesn't it, go? X minus 7, x plus 1. But are those my intercepts, minus 7 and plus 1, or are my intercepts 7 and -1? 7 and -1. So your factors are not your intercepts. The values that make your factors 0 are your intercepts. So you got to be careful not to confuse the two of them. Always check, does it factor? If it doesn't factor, which most of them probably will, if it doesn't factor, you got to do the quadratic formula. And then you got that chaos like you were recording those things from the other day. Those complex numbers. They weren't fun, were they? No. Okay? So always check to see if it factors, and then your factors, okay, get set equal to 0 to be your intercepts. Okay, so x squared minus 6x minus 7, it factored your factors, so your intercepts are 7 and -1. While I have this on the screen, where's the y-intercept? Zero, -7. Does it open up or down? Up. Where's the axis of symmetry? Opposite of -6 over 2. So your axis of symmetry is at 3. So I now have a whole bunch of things I could do to graph this without even having the vertex, all the vertex, okay? I know it hits at 7 and -1. I know the vertex is somewhere at x equals 3. I do the other part of the vertex. So opposite of 36 divided by 4 plus -7 is down there at -16. Okay, so my vertex is 3, -16. All kinds of little things can be used to help graph the parabola. All kinds of little things. Okay. Hanging in there? We good? Okay. Well, I don't want to go too fast. All right, now we have a task, and I'm going to make this as simple as possible. There is a mechanical way to do this that it isn't horrible. It's just time consuming when there's an easier way. And I'm not a huge fan of, in certain cases, depends on the class. If I'm in a pre-calc class, they're doing it the hard way, okay? But there's an easier way to change this to vertex form. So simple, okay? So first of all, we already know, I'll do it in a different color. I'll call it H. We already know A is 2. A is A. So we already know that. I find the vertex, that's H and K. I find the vertex, I just got to plug it in. And I've rewritten it. So I find the vertex, I can rewrite this parabola from 2x squared minus 8x plus 12 to vertex form. That's all I got to do is find the vertex and plug it in for H and K. So, all right, I'm going to let you find the vertex. I got to take a drink of water. I've been going too fast. I haven't given you something to do yet, so you're up. Find the axis of symmetry first, then find the y value, and that's your H and K. If you have any questions about what you're calculating, how to calculate it, or if you're correct, I'll tell you. And the axis of symmetry. They do minus b over 2a. Because your axis of symmetry is minus b over 2a. And then your y value is minus b squared over 4a plus c. So that's what you want to find. Okay? So you want to find so your x value of your h, let's just do it this way. Okay, Ken? Your h value of your vertex is minus b over 2a. The k value of your vertex, well, this is your x value, so h, and this is your y value, k, are these two calculations right here. So you take your a value is 2, your b value is -8, and your C value is 12. You plug them into those two little formulas. There's a way to do it in the graphic calculator automatically, but this is just a fact. You couldn't see your vertex, if you couldn't see the bottom of the parabola, it would be just as long to find it on your graph as it would be just to calculate the thing manually. So while graphic calculators, I think, are wonderful tools, there is a valid reason to do it computationally. Oops. So that's what you plug it in. That's a 2. I mean, you don't have to do, I mean, if you can do the calculations mentally, you don't have to write it all down. That's perfectly fine. You got it? Open the screen up. Open up. Not sure why it won't open up. I think my computer's messed up. 2 and 4. So when you do minus b over 2a, you get the opposite. Negative 8 over 4 is 2. Minus b squared, so 64 over 8 is negative. The opposite of 64 over 8 is negative 8 plus 12 is 4. So you gotta be careful with this one. You're squaring b, but then you're taking its opposite. So negative 64 divided by 8 plus 12 is 4. And there's your vertex form. There's another way to do this algebraically by completing the square, but if you have here's the thing. If you have a quadratic function where that linear term on the x is an odd number, including that 2 that's sitting there, that's a mess. So working with the integers, if you get a fraction, well, okay, that's fine, just plug it in. Because it was positive 2, it stays x minus 2. If my vertex, my x value was negative, it would become x plus, not x minus. So you just got to be careful about that. The sign does matter. Okay? Ken, are you hanging in there? We should do another one, shouldn't we?
Really, I'm kind of lost at this point.
Okay, we'll do another one. All right, let's do y equals x squared plus 12x plus, I don't know, 8. Let's do that. So we want to write it in a times x minus h squared plus k form. Okay? So we're just changing it from standard form to vertex form. To do that, I just want to find the vertex and rewrite it. That's all I want to do. I don't want to go through a whole bunch of chaos if I don't have to. So my a value is already 1. Okay? I just got to find, I'll just do a different color I got to find that, and I got to find that. So we're just going to manually calculate these. All right, what's my a value, Ken? 1? And
Like I said, I'm still kind of.
okay, A is your quadratic coefficient. Okay. B is, what's the B value? $12?
I have no idea.
Well, okay, so here's what do you see the relationship between, okay, that's what I'm doing right there. I'm pulling out the coefficients of my quadratic. So my A value is 1, my B value is 12, my C value is 8. So it's the numbers that are in my function that I'm using to plug in. Okay? So I'm going to calculate the vertex using those two formulas. So my X value or my H value, okay, the X value of the vertex, in this case it's H, so call it what you want. H is the opposite of B divided by 2A. So I'm going to plug in B and A. So I'm going to do the opposite of 12 divided by 2 times 1, and that gives me -6. The K value is the opposite of B squared divided by 4A plus C. It's just a formula. So I'm going to do the opposite of 12 squared divided by 4 plus 8. And that's going to be -144 divided by 4 plus 8. That's -36 plus 8 is -28. That's my K value. There's my H value. Okay, so I just plugged in the numbers from my quadratic into these two calculations, and that's going to be H right there, and that's going to be K right there, because that's your function. Okay, good. Now, so since it's -6, that turns into, so X minus -6 makes this +6, and then the -28 is just a -28. That's it, and we're done. I'm going to assume that the ALEKs are not going to give you a value of your linear term, that B value that turns out to be odd and forces you to get a fraction, because I don't think that's what you're going to see. I think you're going to see something that would be not too terrible, okay, not too painful. All right. Better? Okay. Now, so does anyone want to go through any more graphing ones? Any more graphing ones about digging through the vertex and graphing? Because there's just a couple more graphing ones I kind of zipped over. But there is something on the PDF. There's something you got to analyze. It's not horrible. It's really quite simple. It's just about the vertex, okay? It's just about the vertex. So another vertex calculation. I'll do it this way. Instead of going to the PDF, let me just do it this way, because I want to be able to write without having to go back and forth, and it's just going to be a mess. Okay, so here's my function. -3x squared. And then I'll go to the PDF for that application problem. And that also is just a vertex thing. So a lot of things in this section are about the vertex, axis of symmetry, okay, and then a little bit of graphing. So the question for this, there's 3 questions. The first question is, does it have a minimum or a maximum? Okay, so what do we say about that? So let's answer this question. Does the graph open up or down? It opens down. When it opens down, the top of the parabola, the vertex, is the maximum possible value. has a maximum because it opens down. So the -3, so it's going to open down, and the vertex is a maximum value. Now, it then says, where does it occur? And then it says x equals, so it wants to know the x value of the vertex. So it occurs at minus b over 2a. Put in the opposite of -24 divided by 2 times -3. So Ken, I'm just taking the values of a, b, and c out of my function. A is -3, b is -24, and c is -51. So when my quadratics in standard form, a, b, and c, just like the quadratic formula, I'm just picking out a, b, and c. And I'm going to plug them in. So opposite of -24 over 2 times -3, 24 over -6 is -4. And then it asks, what is the value of the maximum or minimum? So the maximum occurs at -4, but then they want to know, what is it? That's the y value. Oops, move it up. And that's the y value. They don't say y equals, they just ask for the maximum value. So the y value is minus b squared over 4a plus c. So it's that calculation to get the y value of the vertex. So since a was, so b is still -24, a was still -3, and c was -51. Well, I can't do that crap in my head. Well, I probably could, but I'm not going to. Okay, so whatever that turns out to be. -576 divided by -12 plus -51 is a pretty, whatever that is. Wherever that is. I think it's -51. Yep, it says -51. I don't know what it is. I know it's this. Whatever that turns out to be. -3. Oh, that wasn't bad, eh? Okay, so it's just a vertex problem. It's just making sure you understand it opens down, it has a maximum. It opens up, it has a minimum. Where does that maximum occur? X value of the vertex. What is it? Y value of the vertex. Okay, so all that stuff, okay, so now I can go back to this and I can say, yes, my memory didn't fail me today, okay? So when you pull, Ken, when you pull the numbers out of the function, you're using them to find all of these things for your parabola. And your vertex of your vertex form, y equals a times x minus h squared plus k, your vertex, the h value is that one, and the k value is that one. So I know it gets confusing because you got, well, wait a minute, it's x and y, but it's h and k. That's just a general pattern that gets used. Actually, h and k is the pattern for circles, ellipses, hyperbolas, parabolas, every conic section. H and K, and every other thing models the transformations. It's pretty consistent in almost every book and every function. So you just have to kind of help make that transfer. H and K is an ordered pair. Yes, H is an X value, K is a Y value. Okay. Good. Any questions at all about, I hope I didn't go too fast. If I did, I hope someone would say, hey, slow down. Okay, I hope I didn't go too fast. A lot of it's just graphing. And if you have a graphing calculator, I would use it. It's so efficient to get a lot of that stuff because you can do it quickly. Does anybody want that graphing calculator on their computer? All right, hang up for a few minutes. I'll put it on there. It's really quick. Zoomers, how are we doing? We good? It's 1, 2, 3. Come on, Brady, Cole, Calvin. All right, that's better. All right, have a good weekend. If you don't have any questions, we're out of here. Hannah, if you would please just send me that stuff, I'd be appreciative. I kind of remember from everything, but I don't want to make an error, so.
Yep, I actually already shot you an email.
Oh, perfect, great, thank you.